You're falling towards Jupiter, and you have about an hour before physics turns you into something unrecognizable. From this distance, the planet looks almost peaceful. A swirling artwork of orange, brown, and white bands stretching wider than 12 Earths side by side. But this is the largest planet in our solar system. A gas giant so massive it almost became a star. And it absolutely does not care about you. Your spacecraft has failed. Your orbit has decayed. Gravity is pulling you down at accelerating speed into something so hostile that calling it deadly is like calling the sun a bit warm. What happens to a human body falling into Jupiter isn't just fatal. It's a cascade of increasingly creative ways the universe can disassemble matter. So let's follow your descent from the edge of space to whatever ending awaits deep inside the King of Planets, and discover why Jupiter might be the worst place in the solar system to fall. 1. Into the radiation. Before you even reach the atmosphere, Jupiter tries to kill you with something invisible. You're passing through the planet's magnetosphere, a magnetic bubble so enormous it would appear 5 times larger than the full moon if we could see it from Earth. Inside this bubble, Jupiter traps charged particles, electrons and ions, accelerating them to nearly light speed, and creating radiation belts that make Earth's Van Allen belts look quaint. The radiation here measures about 20 million X-rays worth per day, enough to deliver a lethal dose in minutes, even through spacecraft shielding. Your cells are being shredded at the molecular level. DNA strands snap like dry twigs. If you were somehow still conscious, you wouldn't feel it. Yet radiation damage is silent. But your body is already dying in ways that cannot be reversed. You might have hours left, but the countdown has started. And radiation is just the opening act. Jupiter hasn't even touched you yet. 2. The atmosphere arrives. You hit the cloud tops at over 180,000 kilometers per hour, roughly 50 kilometers per second. At this speed, individual air molecules become bullets. The thin upper atmosphere, mostly hydrogen and helium, compresses against your body so violently that it heats to tens of thousands of degrees. You're not burning. You're becoming a meteor, surrounded by a plasma sheath hotter than the surface of the sun. Any remaining spacecraft hull vaporizes instantly. Your body does the same. Flesh, bone, water, all of it converts to superheated gas in a fraction of a second. There is no pain because there is no time for nerve signals to travel. You go from human to atomic vapor between one moment and the next. But let's imagine, for the sake of understanding Jupiter's full horror show, that you somehow survived this. Let's say you're in an indestructible capsule with perfect heat shielding, falling through the atmosphere at a more reasonable speed. What then? Well, then things get interesting in completely different, terrible ways. 3. The cloud layers. Your capsule plunges through Jupiter's famous cloud bands, those beautiful stripes that make the planet look like cosmic marble. Up close, they're less artistic. The white zones are rising plumes of ammonia ice crystals, churning upward at hundreds of kilometers per hour, in storms that dwarf Earth's hurricanes. The brown belts are descending flows of ammonium hydrosulfide. Yes, that smells exactly like you think it does. Mixed with organic compounds that give Jupiter its color palette. Lightning flashes around you, each bolt 1,000 times more powerful than Earth's strongest strikes. The wind screams past at over 600 kilometers per hour, but you barely notice because you're falling faster than the wind can push. Temperature climbs from minus 150 degrees Celsius near the cloud tops towards 0 as you descend. Pressure builds. At this depth, about 50 kilometers down, the atmosphere presses at you with the weight of Earth's atmosphere at sea level. You're not even 1% of the way to Jupiter's core, and already the air is thicker than anything on Earth. The planet is just getting started. 4. Into the abyss. You fall deeper, far beyond where any probe has survived. Sunlight faded to blackness hundreds of kilometers ago. Temperature hits 150 Celsius. Then 300. Then 1000. Your capsule's hull groans under pressures that climb past 100 atmospheres. Then 1000. then higher. Outside, hydrogen gas becomes so compressed it starts behaving strangely. Around 10,000 kilometers down, pressure reaches 2 million times Earth's surface pressure, and temperature hits 10,000 degrees Celsius, as hot as the surface of the Sun. At this point, hydrogen undergoes something called a phase transition. The gas becomes so dense, so hot, that electrons are ripped from their atoms and flow freely. Hydrogen becomes metallic hydrogen, a liquid metal that conducts electricity, something that only exists in laboratories for microseconds before the equipment explodes. You're falling through an ocean of metallic hydrogen, an alien sea under such extreme conditions that chemistry, as we understand it, stops working. This ocean makes up most of Jupiter's interior, a layer perhaps 30,000 kilometers deep, swirling in massive convection currents that generate Jupiter's powerful magnetic field. You're still falling. 5. The core question. Somewhere down here, maybe 60,000 kilometers below the cloud tops, something solid might exist. We call it Jupiter's core, but we're not certain it's there. Models suggest a rocky and icy ball, perhaps 10 to 20 times Earth's mass, compressed under pressures of 100 million atmospheres and temperatures of 30,000 degrees Celsius. At these conditions, rock isn't rock anymore. It's a plasma soup of silicon, iron and oxygen nuclei swimming in a sea of electrons, behaving more like liquid metal than stone. If your indestructible capsule somehow reached this deep, it wouldn't land. There's no surface. You just sink into progressively denser material until even the concept of falling becomes meaningless. You'd be embedded in matter so extreme that atoms are crushed nearly into contact, in heat that would vaporize any normal material instantly, in darkness and pressure so profound that it's closer to the conditions inside a star than anything on a planet's surface. This is where your journey ends. Dissolved into Jupiter's interior, recycled into the churning depths of a planet that has consumed countless comets and asteroids over billions of years. 6. The survivors. Strangely, things do fall into Jupiter and survive, just not in the way you'd hope. In 1994, comet Shoemaker-Levy 9 broke into fragments and slammed into Jupiter's atmosphere. Each impact released energy equivalent to millions of nuclear bombs, leaving dark scars in the clouds larger than Earth that lasted for months. The comet was destroyed, obviously, but its atoms, carbon, oxygen, nitrogen, all the building blocks it carried from the outer solar system, became part of Jupiter. They still swirl in those cloud layers, mixed into the storms, circulating through the atmosphere. In a sense, the comet became Jupiter, its matter absorbed into the giant's vast inventory of elements. The same would happen to you. Your atoms wouldn't be destroyed. Matter can't be destroyed. But they'd be redistributed. The carbon that made your muscles, the calcium in your bones, the iron in your blood, all scattered through Jupiter's atmosphere, eventually sinking deeper, cycling through the clouds for millions of years. You wouldn't die so much as dissolve into the planet, becoming a permanent, if dispersed, part of the solar system's largest world. 7. Why Jupiter matters. This thought experiment reveals something essential about planets and the universe. Jupiter isn't just a bigger Earth made of gas. It's a fundamentally different type of object, a failed star. A planet so massive, its interior reaches stellar conditions without quite achieving fusion. Understanding what happens when you fall into it helps us grasp the extremes of pressure and temperature that exist in our solar system, the strange states of matter that form in conditions we cannot replicate on Earth, and the boundaries between gas giants and brown dwarfs and stars. NASA's Galileo probe, which plunged into Jupiter in 2003 after orbiting for years, transmitted data for 58 minutes as it fell, revealing wind speeds and atmospheric composition before pressure and heat crushed it silent. The Juno spacecraft, still orbiting today, peers into Jupiter's depths using gravity and magnetic measurements, building maps of a world we can never visit. These missions are our only way to explore the interior of a gas giant, to understand the physics that governs most of the planets in our galaxy. So while you personally would survive roughly 0 seconds of actual Jupiter falling, the knowledge we gain from imagining and measuring that descent helps us understand the most common type of planet in the universe.